Up to this point, we have been running all of our ROS2 C++ nodes independently, with each node needing its own dedicated terminal to run. We have also had to open extra terminals to do actions such as setting parameters. Launch files are a feature in ROS which allow you to launch multiple nodes and configure them, all with a single command. In this lecture, we will create a launch file to launch our RPM publisher node. So the first thing we will do is open up VS Code and create a new folder in our package called launch. Within our newly created launch folder, we can go ahead and right click on it, hit new file, and we will call this file rpm_node.launch.py. Now I know this may be a bit confusing to have two file extensions in a file name. Well, in ROS2, launch files are made from Python code, thus why we need to end it with .py. But essentially, the .launch portion of it is a tribute to ROS1 launch files, which used to use XML syntax rather than Python code. Just know that it's generally accepted to have the word launch near the end of the launch file. If you wanted to, you could use an underscore rather than a period before the word launch. Now, I know this is a C++ course, but trust me, these launch files will be fairly straightforward to write, even if you are not experienced in Python. For this Python file, we are going to be importing functionality from the launch module. Specifically, we'll be including launch description from launch and node from launchros.actions. Please note that this is not the same node object from the ROS client library we have been using in our other C++ nodes. Using the import Python keyword is similar to the include statement in C++, and the from Python keyword is somewhat like defining a namespace or typedef in C++. In order for the ROS2 launch command to interpret this Python file, we will need to have a function called generateLaunchDescription in it, which returns a launch description object. In Python, we don't need to specify return data types, so we declare functions using the def keyword. This launch description object will contain a Python list, which is like an array of things we want to configure or run in this launch file. In this case, we just want to launch our RPM node, so I will create a node. On the screen, I show you the source code for this node class, which contains all the optional parameters you can include when launching a node. You can check out the GitHub page for this file to read through the code as well as the documentation strings, which give a bit more context. For our node, I will specify the package, which is our Udemy ROS2 package, our executable, which is RPM pub, and the name of the node, which I will just call RPM pub node. As I mentioned before, you can also use the launch file to configure parameters. We simply specify the parameters argument, which will be equal to a list. This list will contain Python dictionaries, which are denoted by curly braces, which have key value pairs. So I can set our constant RPM value parameter we created in the previous lecture. If you want to add more parameters, simply place a comma and create another dictionary with another key value pair. But for now, I will just leave it as the single RPM value parameter. I just wanted to show you how to do it for multiple in case you ever wanted to try it out. If I wanted to add more nodes, I could simply add them to the launch description list. You can then include all your node details like we just did for our RPM node. However, for now, I will keep this single RPM node, so I'll go ahead and delete this new node. That's all we need for our launch file, so I can go ahead and save this file and head over to our cmakelists.txt file. So in order for our launch functionality to work, all we need to do is create another install function, which I will just put after the one we currently have to set up our C++ nodes. Within the install function, we will use the directory keyword, and the directory we will be including is our launch folder. Then we will point the destination location to the share folder, followed by the project name. Okay, with that, I'll save the file. And now we can go ahead and recompile our workspace so that we can utilize this new launch file. So I'll go ahead and compile it in VS Code. All right, now I'll go ahead and open up a terminal, change into our workspace directory, and source it. And now we can run our launch file using the ROS2 launch command, which takes in the name of the package and the name of the launch file. In this case, we will launch our Udemy ROS2 packages rpm-node.launch.py file. Alright, so we can see that it is running. Now if I open a new terminal tab, I can check to see that the node is running by running the ROS2 node list command. And we see our RPM node is indeed running. Then I can check to see if the RPM val parameter has the value we set in the launch file. So here we see the double value of 5.0, which is what we set in our launch file, compared to the default value, which we have in our node, which in this case is 100. So we can see that indeed the parameter we set from the launch file took precedent, and it was declared when we launched this node. For good measure, I can go ahead and list the topics, and I can go ahead and echo our RPM topic to see it's working as intended. And so here we see the data value of 5.0, which is what we set in our launch file parameter. So congratulations, you have successfully launched your own node using a launch file. It's worth noting that launch files can be used to run external system commands too, and we can do this with the execute process object, which we will have to import from the launch.actions module. Then within our launch description list, we will add an execute process to run a command. In this case, I will run the ROS2 topic list command. This command will be the value of the CMD argument, and we will split up this command up word for word in a list like so. Then I will set the output argument to screen, which means the output of this command will show up in our terminal. With that, let's save the file and recompile our project. And we see it recompiled really fast, and that's because we are using the symlink install, so the only changes we made were to our launch.py file, and so since these are just being linked, it's actually really fast to recompile. So there's not much extra we have to do. So we could have actually gotten away without rebuilding the file. So I'll go ahead and close this. And I'll go ahead and clear the screen and rerun our launch file. Here we see we have one info print statement, which says RPM pub-1. This 1 symbolizes that this was the first command in the launch descriptions. Then we have another info print statement, which says ROS2-2, since ROS2 was the first part of our execute command, and then symbolizing this is the second command in the launch file. Below, we can see more print statements coming from our ROS2-2 instance, which in this case is the result of our ROS2 topic list command. We can see our RPM topic is indeed being published to. Great! You have learned how to use launch files to automatically start up ROS nodes and run terminal commands. Let's review what we learned. So in this lecture, we learned about launch files and how we can use it to launch and configure multiple nodes. Now, of course, we do this with the ROS2 launch terminal command, which takes in the package name and the particular launch file that you want to launch. We then created our own launch files using Python. Now, I know this is a C++ course, but we were able to utilize the Python syntax to import in the necessary dependencies, such as our launch description, node object, and execute process objects, put together our launch description within a generate launch description function, which is what gets called when we run our launch Python file. We then configured a node object within our launch description, which included our package name, executable name, the name that we want the node to take when it's launched, as well as set any default parameter values. We also looked at how we can configure an execute process object within a launch description so that we can run terminal commands within our launch file. So in the case of this lecture, we ran the ROS2 topic list command and outputted the topics of that command to the screen.